In this question, we want a power series for the antiderivative because we're asked to integrate the series expansion term by term for the indefinite integral. So we want capital F. And so what we can do is we can take each of the terms, we can integrate each of the terms indefinitely with respect to x. Kind of a pain to write this whole thing out. There we go. So we want to evaluate the indefinite integral for each of the terms. So we can look at the partial sums, evaluate the indefinite integral for n equals, we start at n equals 1. So if you plug in 1, 1 plus 1 makes 2, negative 1 squared makes a positive 1, and then plug in 1 in here, then you've got 2, x, and then 2 times 2 makes, 2 times 1 makes 1, 1 minus 1 makes 1. This is 2x to the first power for the first term. That's what happened when we plug in n equals 1. If you plug in n equals 2, then it's actually going to be subtraction here, because 1 plus, if 2 plus 1 makes 3, negative 1 to the third power is negative 1, so now we're subtracting 2 times 2 makes 4, and then plugging in a 2 up here, 2 times 2 makes 4, 4 minus 1 makes x to the third, and then we're back to plus, it's alternating, right? N equals 3 gives us 6x, 2 times 3 makes 6, 6 minus 1 makes 5, and then plug in n equals 4, so it becomes minus again, so this is 8x to the 7th power, dot dot dot, keeps going, right? So if we evaluate the indefinite integral for each term, this is just x squared, this is just x to the 4th, this is x to the 6th, antiderivative here, right, because the 6 would come down, reduced by 1. So it came out nice and clean, x to the 8th, it keeps going. We just need to put that in the form of a power series. So we sum from n equals 1 to infinity. The power is always even, so we're going to do 2n. But we also have an alternating term, so we have to do negative 1 to the n plus 1 power times x to the 2n power. And I said n plus 1 because I need the first term to be even. So when you plug in n equals 1, I need this to be, not even, positive. I need the first term to be positive. So when you plug in n equals 1, we get a positive term. I think that's it.